Welcome, Zome. Hello, everyone. Wow, it is a really amazing view from up here. Truly amazing. So hello, everyone. My name is Igor. This is Paul. So today, guys, we'll be talking to you about Zome Energy Networks and what exactly we're trying to do in the clean energy space. So let's start with a story. So August 14th, 2003. As you guys might observe, there's a really weird black spot on that map. That was a blackout that blacked out most of the northeast United States. What happened was a power plant in Ohio lost essentially ability to produce energy for about 2 minutes and 30 seconds. For 2 minutes and 30 seconds, it was not producing anything. The cascading effect resulted in that lasted for more than 16 hours. Now, this is given our existing infrastructure where we can essentially always up the ante and produce as much energy as we want. Now, as we transition over to the green economy and we get rid of coal, fossil fuels, coal, nuclear, etc., we now have variable supply, meaning that if you have solar panels and wind, and there is no wind or there's a few clouds in the sky, well, you have a problem, right? Because demand is now variable and the supply is now variable. And the moment one is bigger than the other, you got blackouts. So, since there's no feedback loop. So when what we're really trying to do is really close the gap. When we say, look, just because we have variable demand, we should also be able to adjust our supply, if at the very least to prevent the blackouts that will happen in this new green economy. So in order for us to do that, and how do we actually transition to that model, right? That's the beginning of that journey. You get to hear a lot of talk about, oh, smart buildings, oh, IoT, oh, smart cities. Well, the city is not going to wake up one day and just be smart. That's just not going to happen that way. So the question is, how do you actually get to the smart cities? And that's exactly what we're also trying to do and answer that question. So the idea is, what we usually start with buildings. We go into the buildings and we instrument it from the connectivity perspective, add all the connectivity pieces, add the smart devices, specifically thermostats and water heaters, because that's what consumes the most electrical energy. First, you have one building, then you also add electrical vehicle solar panels to it, and you go building by building by building by building, and over the course of 5 to 6 years, then you can actually get to a smart city of tomorrow, right? But you need to have a roadmap how to get there, and that's exactly what we really focus on. So we developed essentially a hub that we end up putting into every individual building in order to enable connectivity to all these smart devices in these buildings. We're at CES, we want the award for it, but ultimately speaking, a lot of it just deals with how do we connect all the high energy consuming devices to our system so we can actually curtail the demand. Go ahead. Yeah, that's not. All right. So right now, let's just quickly jump into the demo. All right, so while Paul is trying to get us to a website, I'm going to just tell you guys exactly what we're going to show you. So right now in Portland, we have a live deployment. We have about, I think it's about 150 kWs that are under our control. And what we're going to do for you guys live today is we're going to curtail that demand by about 50 kilowatts. That means that our system is going to reach out to about 250 different homes and adjust the values in those thermostats and water heaters in order to curtail 50 kilowatts of power. And this is going to be all happening within 1 or 2 minutes worth of time span, which is going to be very, very similar in case of an event, in case of a power failure, in case of a spike in demand, or in case of a problem with supply. So what you kind of see, you can see our deployment. You can kind of see our deployment in Portland. So we have 252 devices that are currently connected. Total power consumption is about 1/4 of a megawatt. And out of that, about 60 of that is curtailable. Why only 60? Well, because you can't exactly turn off people's PCs and water heaters and then be happy about it. And a lot of our time that we actually did spend was figuring out how can we actually curtail power in such a way that you won't notice it. Meaning that if I'm going to turn off your thermostat right now, you're probably not going to notice the fact that it's off just in this immediate second. You will probably notice it 5 minutes from now, 6 minutes from now, when that temperature is going up or going down, depending on. So what we have in the background is a set of very complex algorithms that actually play with those settings as you go along to maintain the illusion of the fact that your temperature hasn't really changed, that your power consumption hasn't really changed from your quality of life perspective, but in reality, it does. So right now, Paul has scheduled an event. Looks like we're curtailing 60 kWs of energy. So we're going to have to wait for it actually. So right now what's happening is we're reaching out to all the devices in the background and sending them live commands, telling them tone down the thermostats, adjust the temperature on the water heaters, etc. So while we wait for that to happen, let's take a look at one of the previous events that we ran in the past. So this is the kind of stuff you can expect. You can see what was the actual demand, what was the projected actual demand with our energy curtail, what was the actual demand, right? And you can actually shave off all of that excess. As you can see over here, you can see how closely do we actually follow the projected demand and supply of what we're actually saying that we're going to save versus what we actually are saving. So it looks like, when did you schedule it for 7? Okay, let's see if it's going to start right now. Oh, there we go. It's running, so let's open it up. All right, well, it's just been a minute, so no data points yet. We'll be over there, guys, if you want to come over and see how that event is running. We reached out to people. We told them we're going to be doing it, so they know about it, that they will be experiencing some inconvenience, but that's kind of where we're at, and be more than happy to talk to you guys about the technology from that perspective. And Paul, just keep it up running, so as we're kind of answering the questions, you can kind of see the updates behind me. So on that point, that's pretty much everything I got for you guys. Any questions? Great question. So from the business perspective, we bring this capacity to the utilities, and we tell them, hey, we have 60 kilowatts, quarter of a megawatt available for you guys to tap into whenever it's necessary. In a lot of cases, utilities want to curtail the energy consumption, even when it's not not even when it's a blackout situation, but when the energy is just really, really expensive, and it's cheaper for them to pay you not to consume electricity than to buy it from a third party. So essentially, utility would pick up the bill, they pay us, we pass most of that payment over to the people who actually own the devices, and we keep roughly 10 to 15% of that. Any other questions? Good question. So right now we do it in 2 different ways. The first way is obviously through Wi-Fi. So if you have like Nest, Hive, Ecobee, etc., there's obviously direct API communication. So that's the easy part. The harder part is, okay, well, you go into a big apartment building and there's all these devices. How do you ensure connectivity? So that's what the hub that we develop is actually doing. So that's what the hub is actually doing. It actually creates a mesh network in the apartment among all the devices that we go in and install. So that's how we ensure the connectivity, is we're actually going in and making the existing building that's currently out there and live a smarter building by introducing both the wireless connectivity and the smart devices that connect to that, can connect to that network. Also a very good question. So we've been primarily focused on residential and light commercial. As you probably know, the industrial DR events have been around for God knows how long, and there's a lot of very big players in that area. That's why we really started to avoid that. So like industrial DR has been around probably for 30 years, and it's a very well-known field. And what ends up happening is energy companies actually want to do like that. They actually literally pick up the phone and call like big industrial facilities and tell them to tone it down. They just never bothered to do that with light commercial and residential, because there was never really a means to call 100,000 people, right? With IoT, you can finally do that. So it is also kind of the answer, yes, to a certain extent. There's actually not a single company out there right now. Well, I'm lying. There is one company out of San Francisco right now that's doing similar things to what we do. But yes, that's exactly what differentiates us. We're actually tapping into this residential and light commercial markets. Yes, there's actually three different levels of machine learning models that are operating on a background. The first machine learning model represents the behavior of the system and actually understands what is the power consumption on the system at the high level. Then there is a machine learning model that learns the behavior of every single individual device and what is the rate of consumption of that device. And the third level of machine learning model is actually how do you transform what comes out of the thermostat into energy consumption. Right? Because in a lot of cases, the thermostat doesn't tell you, oh, your HVAC unit is consuming, whatever, 1.5 kWs. It'll tell you the temperature is 30. That's kind of that, right? So there's another machine learning model on top of that to actually arrive to that energy consumption number. Okay, thank you very much, guys.